Hello, I'm Brian.
I'm John.
And I'm Kyle.
So in this drawing, there's an elephant in the top left corner, and basically there's a lake right there, and there's a dog which is thinking about how many of it would take to be like the size of an elephant. So when the elephant goes into the water level rises, and the dogs suddenly think of a plan to figure out the measurement. So the dogs basically go into the water, and the water level rises. And in the next scene, when more dogs get in, the water level rises to the same height as the elephant. And so they figured out that the volume of 6 dogs is equal to 1 elephant.
So in our monolayer lab, we dealt with indirect measurement, which is the use of proportions to find an unknown value. So what we did was we measured the volume of a drop of oleic acid, and we dropped the drop on water, and it spread out to form a circle, or a single monolayer, and a monolayer is a layer that is a single molecule thick. So we were able to find the radius of that monolayer, and knowing the volume of the monolayer, we were able to calculate the height. And because the monolayer is a single molecule thick, that height was the size of a single molecule of oleic acid. So in this picture, the oleic acid is represented by, or actually this is just an example of indirect measurement. So because of the proportion of 6 dogs to 1 elephant, they were able to calculate the volume or the number of dogs that would fit in the water.
In the next scene, which is at the bottom, there's a campfire which is not lit and a bunch of humans around it. And when the campfire is lit, all the humans go towards the fire, and their hands are outwards towards the warmth.
So in our lab, the reason why the oleic acid molecule is formed a monolayer is because they're amphiphilic, meaning that one end is hydrophobic or water-fearing, and the other end is hydrophilic or water-loving. So the hydrophilic end wants to be in the water, and the hydrophobic end wants to be outside of the water. And the lowest energy state for those molecules is for the hydrophobic molecules to be out of the water, hydrophilic molecules to be in the water. So here the people represent the oleic acid molecules, and their hands are the hydrophilic ends that are near the fire, which represents the water, and their backs are the hydrophobic ends that are far away from the water because they don't want to be near the fire.
In the final part, which is on the right side, it shows ocean waves reflecting off a sea barrier, and beneath it, it shows the ocean waves which go past the human. In the very bottom, it shows a dolphin tapping on the heads of humans.
So this basically represents how in those light microscopes that you could usually use in middle school and high school in like your lab, it shows like how those microscopes, when they shine light onto your sample, well, if you have a sample that's actually on the nanoscale level, the light would actually go through, and you won't be able to like magnify, actually see that sample in that nanoscale level. So what we use instead is called a atomic force microscope, which basically uses very small, like middle school needles that rapidly poke along the surface of your sample, and it will basically like visualize what that sample is by using only touch.
So one of the limitations of this drawing was that it was not able to show how light can be used to view substances or samples at the nanoscale and at a larger scale, such as maybe like space. And this was limited because these were all about moderately sized particles or like drawings, and nothing really involved anything much larger or much smaller.
Thank you.
Yeah, hot tip for all the presenters. When you are done, perhaps say thank you. Are there any questions? And then everyone will know that you are done. Good job, guys. Okay, so questions? Yes?
You said at the very end that the drawings didn't adequately show the last part of what kind of drawing would you have thought of to represent that? Your very last point.
I think it would have been possible to show maybe the macro scale using just slightly different situation. So, for example, instead of gathering around a fire, it could be like planets orbiting around like a sun in space, or it could also be used similarly for on the nanoscale with like electrons orbiting around the nucleus of an atom, or like being close to the nucleus of an atom. So I think that maybe using both of those could have shown like similarities between those two scales.
Oh yeah, and please again repeat the question. Sorry, I forgot to remind you guys about that. Ty.
You mentioned that you can use light to basically look at things on the nanoscale. I know that you can do this in an indirect way. What is the way that you can use light to look at things on the nanoscale, even though they're smaller than the wavelength?
So the question was, what are the ways you can use light to view things on the nanoscale?
I'm thinking about it. I mean,
Oh, go ahead.
Well, no, it wouldn't be. It wouldn't be electrons.
I believe he might be referring, just to give you guys some help, he might be referring to the other part of your lab.
Oh, the diffraction thing.
Diffraction.
I think that's what the waves are trying to show. Like, what are they trying to show with the waves?
So another part of the lab was diffraction, which is light. When light reaches an obstacle or an opening, it will separate. So we were able to view how laser was separated by a nanoscale opening and a nanoscale obstacle. So that helped us to measure the size or the wavelength, the size of that that opening, that obstacle.
Yes.
In the drawing, the nanoparticles are trying to stay warm by the fire. Did you test it all with the heat of the water to see whether or not the nanoparticles became more or less hydrophilic?
No, we did not. Or the question was, did we test with by heating, or like test the heat of the molecules to see how hydrophilic they become, or like the oleic acid becomes? And we did not test that in this lab.
Do you have an idea of an answer that if you did heat it up, would something happen?
I believe that heating it up would probably make the oleic acid molecules less hydrophobic.
It might. Actually, I mean, we have not done this, so we're not really totally sure. I mean, I think you would have to go to pretty elevated temperatures to see any sort of difference, at which point you would probably just be boiling water. I don't think anything that approaches the temperature of boiling water, though, would do too much to change the interaction.
But my reasoning for that might be because, for example, if you put olive oil on water and you heat that, then the olive oil at a higher temperature will mix better with the water.
Good answer. Any other questions? If not, actually, before we thank our presenters, and we will, and I forgot to do this for the first drawing, so I will ask that person to stand up next. But first of all, could the person who did this drawing please stand up so we may acknowledge your artistic achievement? Well done.